Welcome to our weekly Ranchers Thursday Lunchtime series. As we know, for the last few weeks, we've been focusing on the management of cattle on wheat and small grain pastures. This week, we've got a excellent presentation opportunity from Dr. Ryan Reuter, talking about setting stocking rates and supplementation of calves on wheat. Next week, we will talk about some other particular management options on using both cows and stocker calves on wheat pasture. And then on the 19th, we're going to have a presentation by Jamie Lynn Farney from Kansas State University, talking about some research she's been conducting with cool season cover crops and how those can be grazed and how we can work those into a rotation. I also wanted to point out that we've also got another series that's scheduled starting December the 3rd, which is going to focus on heifer selection, development, and breeding. We've got an excellent lineup of speakers for that, and would request you to go ahead and register for that one when it comes up. So we've got, as I said, Dr. Ryan Reuter. He's an associate professor and the George Chiga Endowed Professor in the Department of Animal and Food Sciences. Ryan's emphasis is in range cattle and grazing cattle nutrition. He's got a 70% research appointment and 30% teaching appointment. Ryan's research interests include forage-based beef cattle nutrition and management, and incorporating precision management technology into grazing systems, which is some really exciting new area of research that's coming along quickly. Ryan received his BS and MS degrees in animal science from Oklahoma State and his PhD in animal science from Texas Tech University. Ryan and I have been working together for quite a few years on different projects. Back whenever I was in Arkansas and he was at the Noble Foundation is when we first started working together. So Ryan's got a tremendous amount of research in this area, and I'm really excited to see what he's got to present to us. Ryan?
All right, thanks, Paul. I'm gonna share my screen here, see if I can get my PowerPoint going. What's that look like, Paul?
That is your presentation.
All right, sounds like we're good to go. Well, thanks for that introduction, and it's great to be with you guys virtually this afternoon. And as Paul said, Paul asked me about talking about setting stocking rates and supplementing calves on wheat pasture. And that was a perfect topic for me because we've just completed a research study kind of on this topic and investigating a little of the details around this topic and how stocking rates and supplementation kind of interact in wheat pasture systems. And so I'm going to present a little bit of that data to you today and show you what I think we've learned from that recent study and how it can be applied in production. So that's going to kind of be the presentation today. If you don't want to stay for the whole thing, I'll give you the summary up front. The effect of a supplementation program in wheat pasture depends on the stocking rate. That's the thing that we learned. And contrary to what I originally thought, feeding supplement doesn't really stretch wheat pasture. We'll talk about that a little bit more, but what I learned from this study is that not in the way that I originally thought does feeding supplement affect or stretch out wheat pasture. So hopefully that kind of piques your interest about this study and about what we can learn about it. That's basically what we're going to talk about. So we'll get through all the data here and come back to this point right here at the end. So to start the discussion, I thought it might be easiest to kind of talk about stocking rates in wheat pasture, and setting stocking rates, especially for wheat pasture, can be super simple and super easy to do, and it can also be pretty difficult and pretty time-consuming thing to try to do, depending on the approach that you take. The easiest thing to do, and the simple way to do it, is just to use some old rules of thumb. And the simplest one is basically the old rule of thumb that you just allow 2 acres per steer in the fall and the winter, and 1 acre per steer in the spring, and use that stocking rate. And in a normal year, that actually works really good. That's the rule of thumb that I use all the time. And we talk about that one all the time, and it actually is quite effective and pretty close to the mark in a normal year. Another way to get a little bit more detailed in that, but still kind of a rule of thumb, is instead of just talking about the number of acres per steer, you can think about the weight of the cattle per acre that you put on a wheat pasture. So pounds of body weight per acre. And in the fall or the winter, we might say that stocking rate would be 250 to 500 pounds of body weight per acre. So depending on what weight of calf you start with, grazing wheat pasture kind of tells you how many head per acre. But typically a stocker steer for us would be 400 pounds to 500 pounds, somewhere in there. And if we have a good year, we could get by with a little over 1.5 acres per steer of that size, something like that. So it kind of falls in line with that other rule of thumb. You go out to the spring, the rule of thumb there is 500 to 1,000 pounds of body weight per acre in the spring. And in the spring, I mean after jointing, after February. And so that's that's a little bit more detailed way to do stocking rate, but it's still kind of a rule of thumb. So those are kind of the rules of thumb. If you've got wheat pasture that looks like this, those work really well. This is wheat pasture a couple of years ago in one of our studies around Stillwater, and that wheat pasture is real typical. That's just what I expect it to look like. And if you've got wheat pasture that looks like that, it'll kind of support those stocking rates, and that's about all you need to know. These cattle will do really well on wheat pasture that looks like that. The real issue with using these rules of thumb comes in with a situation like this. This is wheat pasture that I took this picture yesterday at one of our wheat pastures out west of Stillwater. And this is the situation we're dealing with this year. And so obviously we haven't stocked this yet, and it's going to be a little while before we get to stock this wheat pasture. But because of the environmental conditions and things that happened this year, this is very much not normal for us. And so the rule of thumb doesn't apply anymore in this situation. And so we need to understand some of the relationships that are going on between the forage and the animal demand, so that we can figure out how to stock wheat pasture when it doesn't fit the normal scenario and the rules of thumb don't apply. So we get a little bit deeper into this stocking rate situation and discussion. And I'll kind of add to this table, extend this table a little bit with a line here that's got forage production. And I'm kind of going back here to a normal year, but in a normal year of forage production, we might expect to have 1,000 pounds of forage dry matter per acre. So not 1,000 pounds wet, but 1,000 pounds of actual dry matter per acre of the forage that's out there when we turn out or graze in the fall and the winter. And if you look at this 1,000 pounds of dry matter per acre, and you kind of compare to the pounds of body weight per acre, you take these two rules of thumb here, and you divide the amount of forage by the amount of animal body weight, you get a ratio here of the forage to the cattle weight of about 3 to 1. And that number is going to be pretty useful to us. Okay, so when we're setting stocking rates, essentially, I kind of mentioned what we're trying to do really is balance the amount of forage that we have available with the demand from the animal. And hitting that balance point is where, that's what a stocking rate's trying to do, is find the balance between those two things. And this ratio here of about 3 to 1 is a pretty good place to be for that balance point. If you look again at the spring, it's kind of the same thing. In the spring, in a normal year, we would expect to have about 2,000 pounds per acre of dry matter in a wheat pasture. And if we've got it stocked at that 500 to 1,000, if you kind of take the average of that again and do this math, divide the amount of forage by the amount of cattle body weight, the ratio is about 3 to 1. So that 3 to 1 ratio there is kind of starts to become useful for us to help us decide how to manage stocking rates. That number is called forage allowance, and we use forage allowance a lot in grazing animal research, and maybe a new concept to some of you thinking about managing stocking on your ranch. Some of you probably have used it a long time and already think this way, but some of you kind of maybe a new way of thinking. And I would encourage you to think about it a little bit and see if starting to think in terms of forage allowance might help you understand more of these relationships a little deeper and adapt to changing conditions. So I do think forage allowance has got a lot of utility in grazing management. Here's some data that kind of goes a little bit deeper into forage allowance. This comes from a paper that Paul actually wrote and published several years ago, kind of a summary paper. This wasn't all of his data, but it was a really nice summary of the effect of forage allowance, which is along the x-axis here on the bottom. This is forage allowance. So it's kilograms of forage dry matter per kilogram of animal body weight. And then over here on the y-axis is average daily gain. And these are in kilograms per day, but it doesn't matter. The relationship's the same if you're talking about pounds per day. But the important point here to think about kind of analyzing this data is this vertical line here is kind of a reference point, and that's at about that 3 or 3.5 to 1 that we were talking about a minute ago. And that this kind of shows you that that's the balance point for what we might call an optimal forage allowance. If you get above 3 to 3.5 to 1 as a forage allowance, average daily gain of the cattle doesn't really improve much or at all in this data. If you go below that 3.5 or 3, if you start going down here below and you get down at a low forage allowance, that really hurts average daily gain. The cattle, that hurts their performance. They can't gain as well. There's all kinds of reasons for that. The big one is cattle can't eat enough forage, basically. So if you're down here below 3 to 3.5 in forage allowance, you would call this pasture overstocked. The pasture can't support the amount of cattle that you've got put out there on it. They can't. There's not enough forage there for those cattle to fully express their potential to gain. Okay. So if you're below there, you're kind of overstocked. The forage is limited. If you're above 3.5 on forage allowance, we might call that pasture understocked. You could think of it as you're wasting forage. There's excess forage available that the cattle can't really use. You could also think about that the pasture could support more cattle than what you've got put out there. So this forage allowance thing becomes pretty useful. And so, you know, this 3 to 3.5 forage allowance is where we would like to be. That's kind of the optimum. The question becomes, you know, what happens if you're not there? How do you respond to management? What management strategies can you take if you're not at the optimum, which often we're not at the optimum. So that's why this forage allowance is important and why I've talked about it a little bit. If you were interested in using forage allowance in your management decisions, you might think, how can I use that? Well, you really only need to know a couple things. You need to know the weight, the amount of the cattle that you've got out there, which is pretty easy to figure. It's kind of, the number of head divided by the acres, head per acre, and what those cattle weigh. So that's pretty easy to estimate for most people. The other piece you need to know is the forage production that you got, and that's harder to estimate for a lot of people. We usually don't think about it in production every day. This is how we measure forage production in research. We'll go out and actually clip it, take samples, dry it, weigh it, and that's a kind of the gold standard way to do it, but it's a real pain. And I certainly don't expect many ranchers or producers to go to that trouble, but that would be how we would measure forage production in some of our research experiments. Another way that you can measure forage production that works really well is to use the height of the plants, the height of the forage. And this is a picture here from Dr. Reuter. He might have already talked to you about this. You might have already seen this, but he's showing here how you can measure, just take a ruler and measure that kind of the average height of the plants. And that height is a pretty good proxy for the amount, the mass of the forage that's out there, the weight of the forage. And for wheat pasture, I'm going back to a rule of thumb again, but for wheat pasture, a good rule of thumb is about 200 pounds of dry matter per inch. So if you go out and measure your wheat pasture, and on average it's 4 inches tall, you can say that's about 800 pounds of dry matter per acre, give or take. And you could use that number to then kind of see where you're at in terms of forage allowance with the cattle that you've got. Again, if you go out and measure it, if it was 6 inches, it would be about 1,200 pounds of dry matter per acre, give or take. So if you're interested in using forage allowance, this will be a good way to get started to understand how much forage you've got, so that you can allocate it to the cattle using forage allowance. Okay. So I kind of already mentioned it, but in a situation like this, these cattle, we would say, typically have good amount of forage. They're doing well, they're gaining well, and in this situation, all the rules of thumb apply, and it's pretty easy to manage that. But if we think about, again, back to that picture of if we're really short on forage, like for instance we are this year, and we know that we've got more cattle than we have forage available, we can't get to the optimum forage allowance. What are some strategies that we can use to mitigate those problems? And the classic one that we would use is supplementation. We often implement a supplementation program to cattle on wheat pasture, and kind of the folklore or the information that we've had before has been that if we feed cattle a supplement on wheat pasture, that's going to help stretch the wheat pasture out, right? So if they're short on wheat pasture, if they're limited in the amount of pasture they've got, we can kind of make up that difference with some supplement, and they won't eat as much, they won't need as much wheat, and it'll make the wheat last longer until we get in better conditions and can grow more pasture. And so that's at least how I used to think about it. And so we did a study on that very question to understand what's really going on there. And after that study, I think about that relationship a little bit differently now. So I'm gonna jump into this research project and show you the data around stocking rates and supplementation and what we did there. Paul, I'm not watching the chat or anything for any questions. So if something pops up and you see one, just jump in and ask it. So this little study that we did at the Stillwater Wheat Pasture Unit, which is right here west of Stillwater. We did the last 2 winters, 2 years. We did this study. We had a good grad student that worked on this. We have 8 pastures there that we used. And so our treatments that we set up, we set these pastures up so that 4 of the pastures had adequate forage allowance. We used the stocking rate so that they were about 3.5 pounds of forage per pound of animal body weight. And then 4 of the pastures, we had limited forage allowance. And we stocked those pastures heavier until we got down to about 1.5 pounds of forage per pound of body weight, that forage allowance. So it's a pretty good difference in forage allowance. The 3.5 I call adequate, and it's kind of the optimum, and 1.5 is pretty limited. And so then the other thing that we did with those pastures was we also had 2 levels of supplementation. So in the pastures that had adequate forage allowance, 2 of those pastures got no supplement, and 2 of those pastures the cattle got 3.3 pounds of supplement per head per day. And that supplement is about 50-50 soybean hulls and wheat midds. So, pretty high energy supplement and a good amount of supplement. 3.3 pounds per head per day is a significant amount of supplement. So we're kind of setting up a little bit of extremes here. We had a pretty big difference in forage allowance and no supplement versus quite a bit of supplement. So we had 2 pastures in each of the forage allowance either got no supplement or a good amount of supplement. And so basically that's setting up giving us the data we need to understand, does supplementation affect cattle differently if they're limited in the amount of wheat pasture they've got? In this study, we weighed the cattle every week. We measured the forage 3 times a week, and we adjusted the stocking rate in each pasture every week so that we tried to keep our desired forage allowance kind of through the whole experiment. These experiments lasted about 84 days each year. So we would actually change the stocking rate in each pasture a little bit every week. If one pasture started to grow a little bit more, we'd add another calf, or if it was getting too low, we'd take a calf out to try to hold that forage allowance there. And I realize I wouldn't recommend somebody necessarily stocking their ranch that way, but that's the way we did it to get the data we needed for this study. So that's kind of the setup of our study. I'm going to jump in and show you some data here. In this graph might be kind of a little bit of a rabbit trail, but I thought it was fun, so we could look at it for a minute. I told you we weighed the cattle every week, and that was a lot of work, and it's got interesting data, so I thought I'd show it to you. This is the weight change in the body weight of each animal in this study over the 2 years. Obviously, there are different animals in each year, but I thought it's kind of interesting if you've never weighed cattle every week and never watched how they gain on wheat pasture over time. This is kind of what growth curves of cattle look like going through a grazing period on wheat pasture. So you can see there's lots of interesting things going on here with these different animals. You can kind of see it smoothed out averaged out across all of them. You kind of get a fairly linear. It's got a little bit of a curve to it, but fairly linear increase in body weight. So they kind of gain about the same rate through the whole grazing period. An interesting thing to look at right over here in this data in 2019, we were weighing the cattle every week, and then right here for about 12 or 14 days, we weighed the cattle every day because we were doing some more intensive sampling. And so you can kind of see all this variation and bouncing around, and that's kind of interesting to look at. If you weigh cattle every day, their weight can change a lot from one day to the next. And so that kind of illustrates to me that when we're weighing cattle for a research project, we need to be really careful. And if we can take several weights in a row and average them, that gives us better data. So that's part of the reason I wanted to weigh these cattle every week, was try to get a really good estimate of what their gain was over the whole experiment. So I don't know if I had the data. I thought it was kind of interesting. If you've never seen it, might be interesting for you to look at. But I just kind of threw that in there as as something else to talk about. But we'll kind of go on and summarize this data here in a minute related to the treatments. This graph here shows the actual forage allowance that we achieved over these in these pastures over these two studies. And what you can kind of see here is we had 4 pastures that we were trying to be at 1.5 forage allowance, and we held those down there at 1.5 pretty well in 2018. And in the spring, as it always does, the wheat pasture starts growing really rapidly. And in 2018, it got away from us a little bit. We couldn't quite hold it down as low as we wanted to. In the spring, didn't have quite enough cattle. But those other pastures, we were able to kind of keep them up at above that 3 or around 3.5. So these pastures had adequate, optimal amount of forage in them. We had a problem this year with that number 4 pasture. It didn't produce like we wanted to, and we weren't able to keep it up there. But so it was kind of an outlier that year. But in the data, it turns out it didn't affect the data too much. But that one was kind of an outlier. 2019, same thing happened. We were able to keep those 4 pastures down here at a limited amount of forage, and then these other 4 up here at optimal amount of forage through the whole grazing period. So we were targeting 1.5 and 3.5, and we were able to do that pretty well with our grazing method through both of these years.
Ryan, we have a question.
Sure.
You have the numbers available to say what the average stocking density was across the whole time?
I didn't summarize that right off top. I don't have that right off the top of my head. I didn't summarize that for this study because that wasn't what I was thinking about. But yeah, I could get that and share it with you. But it was going to be, the average would be fairly close to those rules of thumb that I talked about. But obviously the 2 different forage allowance treatments would be quite a bit apart in the stocking density. The limited forage allowance stocking density would have been about twice what the adequate forage stocking density would have been. So, but no, I didn't think to summarize that overall right here. So to get to look at these at the treatment results again, what I would think here to remember what the treatments were. So we had adequate forage plus supplement, and we had adequate forage with no supplement, and then the same thing in limited forage supplement, limited forage no supplement. So those are the 4 things, the 4 treatments we had, and we're kind of trying to see how these interact. Okay, so there's a lot going on in this chart, but this is average daily gain, and I'm going to kind of walk you through how I see this. Okay, this is forage allowance along the bottom here. So these observations over here are cattle that were limited in the amount of forage that they had. These observations over here are cattle that were basically adequate in the amount of forage that they had. All right. And then again, this is average daily gain in kilograms. The red dots and the red line here are cattle that were not supplemented, and the blue are cattle that did get supplement. Okay. So that kind of sets up this chart. Whoops. So a couple of things to think about. Overall, average daily gain was really good. It was about 1.5 kilograms a day. So we were a little over 3 pounds a day, average daily gain on these cattle. So that's excellent. Another thing to think about here is to see that feeding the supplement improved average daily gain. Okay. So the way to see that is if you look at the difference between the blue line and the red line, that's the effect of the supplement. So the blue line's always higher than the red line. So feeding supplement improved average daily gain, which we would expect. But the big thing here, the thing to notice, feeding supplement improved average daily gain a lot more when forage was limited. So this down here at this end of the range, we get a big difference between no supplement and supplement. And then if you get up here with adequate forage, it's a much smaller difference, much smaller advantage. So in the limited forage, the supplement added about 1/3 of a kilogram per day. And then in the adequate supplement, it added about 1/10 of a kilogram per day. It was about 1/3 of the amount, right, of the increase. So much bigger effect when cattle were limited in the amount of forage that they had. And this makes sense, right? This kind of makes obvious sense with what we think about and what we know about. When cattle don't have enough wheat pasture, you provide a supplement, it really improves their average daily gain. You can take cattle that are limited on wheat pasture and offer that supplement and get about the same performance from those cattle as if you had adequate wheat pasture, right? So you can kind of think about, if you're short on wheat, adding supplement kind of maintains the gain you would expect if you had adequate wheat. And it makes a big difference if you got short wheat pasture. Another way to kind of look at that is to think about that in terms of supplement conversion rate. And this might be a little bit of a new concept for some, but it's real simple. Supplement conversion rate is how much supplement it takes to produce an additional pound of gain. So this is a real useful statistic, and it's just, you just basically calculate how much supplement you need to produce 1 more pound of gain. And by additional, I mean over and above what the forage itself would produce anyway, right? So if you put cattle on a pasture, they're going to gain something. But if you supplement them, they're going to gain more. And so the difference is, the question is, how much supplement does it take to get that more gain, right? That extra gain. And this is similar, you can think about it similar to thinking about it as feed conversion. If you were feed conversion in a feed yard, you would think, how many pounds of feed does it take to get a pound of gain? And supplement conversion is the same way. You're just in a pasture and you're thinking, how much supplement does it take to get an extra pound of gain? And these are measures of efficiency, and they're super useful for evaluating the economic evaluation and profitability of supplementation programs. So in our study, the one we just looked at, if cattle had limited wheat forage, their supplement conversion ratio was about 4-to-1. And if you looked at any of these numbers before, 4-to-1 is pretty efficient. That's a really efficient supplement conversion. And what that means to me, I mean, if we wanted to do the profitability analysis, we could do that. But we'd have to kind of get specific numbers for whatever situation we want to look at. We need to know the price of the supplement, the value of the cattle, all those kind of things. But if you see a supplement conversion ratio of 4-to-1, that's really efficient, and it's likely that most supplementation programs that you would consider, most of them will likely be profitable because this is so efficient. So a 4-to-1 is real efficient, and that means that supplementation is probably going to be profitable in that scenario. In the adequate forage cattle, the supplement conversion ratio was over 10-to-1, so it's much less efficient. Putting supplement into that system when you've got adequate forage, the cattle don't convert it nearly as efficiently into gain. And kind of what that means again is there might be a situation where that would still be profitable, but it's much more limited in where you're going to find a supplementation program that's profitable if the supplement conversion ratio is 10-to-1. You'd have to have really valuable cattle and really cheap supplement to make that work. So that 10-to-1 supplement conversion ratio is much less appealing to me than this 4-to-1 from a profitability potential standpoint. So that was kind of the results that we got from the study, and we got this difference going on here. And of course, I asked the question, why does that happen? Why do we get this difference in supplement conversion efficiency? And so we collected a little more data to try to get at that. And you're probably already thinking ahead of me, but the reason why you get this has a whole lot to do with forage intake in these two scenarios. And we actually, in this study, one year, we actually used some internal markers to get an estimate of forage intake. And it's pretty interesting data. And so that's what this data is right here. This is forage intake. So this is the voluntary intake of just the pasture part of the diet from these cattle. Again, these are cattle that were limited in the amount of forage they had. These are ones that had an adequate amount of forage over here. And what you can see is that when cattle are limited in forage, cattle eat less wheat pasture than normal. So you would that makes total sense, right? So that's kind of this red line. If they had plenty of forage, they'd eat this much, but they're limited, so they reduce how much they eat. So they're all the way down here. The less forage they have available, it restricts how much they can eat. They can't take as big of bites. They have to search more to find the forage that they need. Each bite has less mass in it, and so they just can't eat as much forage, and that makes sense. But what's interesting here is that the cattle that were supplemented and the cattle that were not supplemented basically ate the same amount of wheat pasture. So all of the supplement that the supplemented cattle got, all that supplement was on top of the pasture. And that's why we saw that big response in average daily gain, because they were eating the wheat and they got the supplement on top of it, and all the nutrients from the supplement were in addition to what they were eating from the pasture. And if we had not, when we did not feed cattle supplement but limited the amount of forage, they didn't eat any more extra wheat pasture. So the intake of the forage was the same. But the opposite relationship showed itself when there was optimal forage, when there's adequate forage out there. In that situation, when we fed cattle supplement, it replaced the wheat pasture, right? So they ate the supplement and basically reduced the amount of pasture that they consumed, right? And so that it wasn't a perfect one-for-one replacement, but there was a big difference in the amount of forage that the two groups would eat. So when you see, and basically that explains why there was the supplement was less efficient in this scenario, right? Because we're adding in nutrients from the supplement, but the cattle are not consuming as much wheat pasture, not getting as many nutrients from the supplement, and so that's why this program looks so much less efficient to us when we're looking at the gain of the cattle. So there was this interaction in forage intake that kind of drove that difference in supplement conversion rate. And I think this was important to see and important to understand. And I think it's important for you to understand this relationship as you're making stocking and supplementation decisions on wheat pasture. So I'm going to kind of hit the take-home message here the way I see it from this study, and kind of summarize here. When wheat pasture is limited, supplement will improve average daily gain in that scenario. If you've got limited wheat pasture, if you're below and substantially below that optimal value forage allowance of 3, supplement's going to improve average daily gain. It's going to improve it fairly dramatically. It's going to be pretty efficient, and it's likely going to be profitable, right, in that scenario. But it doesn't really save wheat pasture. It's one way to think about it. If you've got short wheat pasture and you feed supplement, you're not really reducing the amount of wheat pasture those cattle eat anyway. They, if you didn't feed the supplement, they would eat about the same amount of wheat. So the supplement works to improve average daily gain, and it's efficient and profitable, but it's not really working to stretch your wheat pasture or make your wheat pasture last longer. That's not really what it's accomplishing. When wheat is adequate, when you got an adequate amount of forage, you are up around that 3 forage allowance, then supplement will improve average daily gain, but it's much less dramatic and it's much less efficient in that scenario. And it's because it's so much less efficient, it's much less likely to be profitable. Okay. Supplement in this scenario does reduce wheat intake, right? So if you feed supplement, if you got adequate wheat and you feed supplement, the cattle will reduce how much wheat they consume. So supplement does save wheat or stretch wheat when you've got adequate wheat. But the problem is, you got adequate wheat, you don't need to save it, right? That's not the time that we would like to save it. So the fact that it reduces wheat intake here isn't really a benefit, because we've got adequate wheat and we don't need to save it then, right? So that kind of leaves us in a place here. Or what do we recommend if we need to save wheat, if we need to stretch wheat? And I hear people talk about that a lot. So that's pretty hard to do with supplementation, apparently. So if you need to stretch wheat pasture, you essentially need to destock it. And that's the hardest thing logistically to do in farm management, and understand that. And that's why people don't want to do that, and they'll look for other ways to try to stretch wheat pasture. But if you've got a limited amount of wheat pasture, then feeding supplements not really going to stretch it. You're going to have to destock it to try to stretch it. And then the other thing to think about is, if you have adequate or even excessive wheat pasture, that's a great condition to be in. And if you're in that situation, you do want to carefully pencil the economics of a supplementation program before you do it. You don't want to spend money on a supplement that is not going to make a return for you. And if you've already got adequate or even excessive wheat pasture, then it's much more likely that supplement's not going to be able to generate an economic return. So if you got that situation, be careful about pulling the trigger on your standard supplementation program. The other way to manage that, if you've got adequate or excessive wheat pasture, go get some more cattle and stock it heavier. And then if you want to do that, and then you can feed that supplement, and you'll see that really efficient response to the supplementation. But if you add more cattle, then basically you're saying you don't have excessive wheat pasture anymore. You're kind of changing the forage allowance back under optimum. So those are a couple ways that you can manage that. And so that was basically all I had for you today. I really appreciate getting to show you this research that's pretty new. I was excited about it. I thought it was kind of a neat study, and I think came out of it with some real useful things that you can, some understanding of these relationships that you can take home and help you make stocking rate and supplementation decisions in variable environments with wheat pasture. So that's what I had. Thanks for your time.
Thank you, Ryan.
Take any questions.
That's some great research, and really excited to see, start, focusing down on where those supplementation responses are, and trigger points on when we need to start providing supplement to maintain animal performance. We're not going to stretch the wheat pasture, but we can sure keep cattle performing. I've got one question in the chat, and I had a question. before, on this supplementation, is this something that feeding 3 pounds a day, could you double it up and feed it every other day, or do you need to feed that every day of the week?
Yeah, I think you could, I don't think you necessarily have to feed it every day. You could certainly feed it 5 days a week, kind of prorate it out and feed 5 days a week. You could do that and get along fine with it. You could probably go down to feeding 3 days a week. I think in this study we did feed some of the time. We fed 3 days a week and prorated that amount out. And so it's with a lot of supplementation in cattle, the frequency of feeding has less effect than the total amount of supplement over a period of time. And that relationship kind of starts degrading as you get to feeding a higher amount of supplement. But I still think with these cattle, we were targeting about 0.75% of their body weight as a supplementation rate. And I think you can feed that 3 days a week and be still be pretty efficient with it, be nearly as efficient as feeding it every day. So I haven't done that study, but I think you can.
Got some questions coming from chat. So the substitution effect does not apply in limited wheat pasture situations. What if it were a grain-based supplement? And does it have implications regarding your thoughts on creep programs of nursing calves?
Okay, so that's a couple different questions. If it was a grain-based supplement, so a supplement that had a lot of starch in it, I think we would see pretty much the same scenario that we saw. I don't think I wouldn't expect to see much difference really if we used something like corn and soybean hulls or corn and wheat mids, kind of a blend like that. I think we would see substantially the same results. So I think that substitution effect that we're seeing there is driven more by the limited amount of forage and the restrictions on the grazing behavior of the cattle, limiting their forage intake. And so I think a starch-based supplement would do pretty much what this supplement did as well. On the creep feeding, that's kind of a different question to me, and you know, I don't know if you're asking necessarily about creep feeding in wheat pasture, but really the thing I would think about is the discussion I went through on supplement conversion rate. That discussion really applies really well to creep feeding in that situation. And if you look at the creep feed conversion rate or the supplement conversion rate in a creep feeding situation, it's oftentimes greater than 10 to 1. I've seen them be like 20 to 1 or higher. And if you look at what creep feed costs and what the value gain of those cattle are, if the cattle are converting the creep feed into additional gain at like 20 to 1, there's almost no way that's going to be profitable for commercial cattle. So creep feeding typically, in the way it's done traditionally, is usually pretty inefficient, and so rarely do we recommend creep feeding. There are a few specific types of supplements that you could do with creep feeding that kind of change the efficiency and change those economics some, or you can do things like creep grazing, which really reduces the cost of the supplement, the forage that's acting as a supplement, and so that kind of changes the economics sometimes. But that supplement conversion rate is really important to think about if you're buying creep feed. So
a follow-up on that from the person who asked that question as far as the creep feed. Essentially, a creep program will sustain animal performance but not decrease forage demand of the calves, and I think that's exactly what you had just said, and kind of dovetails exactly with this research you showed.
Yeah, Yeah, pretty well.
Got a question about the cost of supplement and cost of gain during the study periods.
I haven't summarized that yet. Don't know that I will. I could, but you know, we used soybean hulls and wheat midds 50-50, and I don't remember what that cost for us. It was $200 a ton or something like that. So the value, I don't even know what the value of the gain of the cattle were, and those are real important figures to focus in on when you're evaluating a supplementation program for your ranch. But I guess the last several years I've gotten where I worry about those less, because in my opinion they're not very useful in a research paper, because they depend, those numbers depend on current prices for cattle and for feed and supplement and all those kind of things. And so if I calculate what it was 2 years ago when I did this study, that doesn't really apply today, or may not apply today. So I was on this study, I was focusing in on trying to do a good job of determining what that supplement conversion rate is and understanding the biology around that, and get that number, so that then when somebody in the future, 5 years from now, wants to evaluate this kind of a supplementation program, they can take that biology rate relationship and apply current prices to it. So that's the way I would recommend, and the way I think about calculating those. So that'd be great, really great to do when you're evaluating a program, but I haven't done it yet because I didn't worry about it for summarizing this research data.
So another question is, what was the protein of the supplement, and how much protein would be required in that supplement for cattle and wheat pasture?
So for cattle and wheat pasture, we don't worry about protein in the supplement. We actually don't need protein in the supplement. Wheat pasture runs in the high 20s in crude protein. It's nearly always above 23%, somewhere in there. And so wheat pasture itself is far in excess of the protein that the cattle need. So we don't worry about crude protein in a wheat pasture supplement. What we care about is the energy value of that supplement, and the kind of the digestibility, how much energy can the cattle extract from it. Wheat midds are in the about 17% protein, and soybean hulls are 13% protein, something like that. And we mixed about 50-50, so the supplement would have been in the ballpark of 15% protein. But that's just because that's just what comes with getting wheat midds and soybean hulls. If you know, it's fine to use corn in a scenario like this that only has 9% protein in it. If we could find a good cheap supplement that was palatable and digestible and all that kind of stuff, that had no protein in it, I'd use that. You know, we just don't need protein in wheat pasture supplementation.
Got a question regarding how many years out of 5 do you perceive this needing this supplement for cattle stocked on wheat pasture at our rules of thumb?
Well, it's a little bit hard question to ask, or hard question to answer, because I think it depends on different producers' approaches as to how they manage wheat. You know, if you're a person that wants to get the right number of cattle for the forage that you grow, and you can buy or stock a different number of cattle and adjust your stocking rate so that you maintain that forage allowance of about 3, then even in a year when you have less forage production, if you reduce your stocking rate to stay in that balance of around 3, you're going to be on the end of that supplementation, or on the end of that curve where supplementation is less efficient every year. If you're a person like a lot of people that I know, and like what I tend to do is uh, overstock my wheat almost every year, then no matter how much wheat I have, I kind of have too many cattle. Um, then you would see the efficient response to supplementation every year, because you're always going to stock it, where you're a little under the optimum. So I really think it's not so much the environment doesn't really make the stocking rate decision for us. The environment kind of makes the forage production decision. The environment kind of dictates how much forage you have, essentially, and then you decide where you want to be on the stocking rate so that you hit the forage allowance where where you want to be, and then that forage allowance kind of tells you what kind of supplementation program you would work for you. So it's hard for me to say how many years out of 5. Some people would be 5 years out of 5. Some people might be 1 out of 5 or 0 out of 5.
Yeah, a lot of that depends on how much you let accumulate, how much wheat forage you let accumulate, and before you stick cattle out. Or like I've seen a lot of people this year, 1st of November, they started putting cattle out no matter what was available.
Right.
Got a question. The interpretation of some of your answers, starch-based supplement does not suppress forage intake. So that's the question.
Well, in wheat pasture, a supplement with some starch in it at the rate that we're feeding, I don't think has a big effect on intake of wheat pasture. Certainly in a different scenario, if you were talking about low quality dormant native range and you fed quite a bit of starch, that definitely has a negative associative effect on intake in that scenario. But at these rates of 0.5% of body weight or somewhere like that, with a supplement that's half corn, or got 30-40% starch in it, something like that, on wheat pasture, there's not going to, I don't think there's going to be that big reduction in forage intake. The rumen biochemistry is different, and it's not set up like a dormant forage for that starch to really have that negative associative effect on intake the same way. So, I mean, obviously it depends on the situation that you're talking about, but
yeah, depends on which end of that stocking rate curve.
Yeah. And it might be worth, repeating this kind of a study with a really high starch supplement and see what it does. See if it's the same. But my gut feeling is that it won't be very much different in this.
So one final question. Getting back to what you were talking about on dry grass, what suggestions for supplementation of bulls on dry grass or harvested hay?
Oh, well, now we're way off of wheat pasture, so I haven't thought about this in a while. So I probably should just let Dr. Lawman or Dr. Beck answer that question. But yeah, I would say on for bulls this time of year on dry grass, bulls don't, if they're mature bulls, they don't have a huge, very high protein requirement. They would be in the ballpark of cows as far as protein and energy requirements. And so if you've got plenty of low quality forage for them to graze on, then I think a few pounds of a high protein supplement would stimulate them to consume as much of that low quality forage as they can, and that's going to be the most cost effective way probably to feed that bull for a while. If you start running short of forage or don't have enough hay, then you kind of start thinking about that a different way. But
All right. Thank you very much. I appreciate your, yes, sir.
Can you hear me okay?
Yes, I can hear you, Dave.
Yeah, I'm in my truck, so I'm talking while driving. I'm not texting while driving. So Ryan, I think it's interesting that your data lines up pretty well with the creep feeding data, and you've talked about that already, but I think it's pretty clear in the creep feeding literature that as forage quality or quantity declines, the creep feeding efficiency, that supplement conversion, improves.
Sure.
And so in our little bit of data with, fall calving cows, it's not too bad.
Okay.
Like you said, it's terrible if you've got a really good summer and you're trying to creep feed through the middle of the high quality forage season.
Right. Yep. That's a good point.
The other thing, Ryan, is I think it's also pretty clear, and it's not wheat pasture, but creep feeding does not appear to reduce the quote. You always hear people say it reduces the pressure on the cows. In other words, calves don't consume as much milk. No, they consume all of the milk. And so whether you're creep feeding or not. So pretty similar in that way too.
Yep. Yeah, I think there's kind of some relationships of how the behavior and the biology works and where the efficiency comes in, and so
yeah. Well, good job. That's really good
supplementation decisions. So
that's really good stuff. I'm gonna mute myself again. Thank you for joining us. That's good stuff. Well, people are gonna get a lot of good out of this video.
Hope so.
Well, thanks again, Ryan, for your presentation. And with that, we're right up against the time limit we've set for ourselves for the Ranchers Thursday Lunchtime series. Be sure and come again next Thursday at 12:30. We're going to talk about some additional grazing management and supplementation issues with stockers and cows grazing wheat pasture. So thank you very much, and see you next week.
All right. Thank you. See you.